everyone, I'm teacher Yuxian and today I'm back again with our RMO preparation videos. Today the question that we'll be dealing with is RMO 2012 round 1 question 6. So let's take a look at what this question is all about. This question says that there are two swimmers at opposite ends of a 30-meter pool. And now they start to swim the length of the entire pool, one at 1 meter per second and the other at 2/3 meters per second. Now, they swim back and forth for a total of 12 minutes. Assuming that there's no loss of time at a turn, we are asked to find the number of times that they pass each other. Now, obviously, when we look at this question, it looks like a travel problem. So, to make things simpler and more visible for us, well, we draw the diagram, which is a 30-meter pool, and the two swimmers will let them be A and B, being on two sides of the pool going towards each other. Now, when will be the first time that they meet each other? What type of question is this? Obviously, we can see that it is a meeting out problem, something that we have talked about before. So for meeting out problem, it is just 30 divided by the sum of their speeds to get the time where they first meet. And that gives us 30 divided by the sum of their speed equals to just 18 seconds. Oh, so let's draw it out on the diagram itself to make it more visible. Oh, A and B would have traveled this much. A, since it's 18 seconds, will have traveled for a total of 18 times 1 meters. While for B, you have traveled for a total of 12 meters instead. No, that is just when they have first met. Let's see when will they meet again. Oh, let's continue on the diagram. Now, A will continue moving on towards the right side. For the next trip that he takes, he'll take another 18 meters. And how will it be represented? He'll go to the end of B, which is 12 meters, and turn back for how much more? Turn back for 6 more meters. And that is what will happen. Now, at the same time, what will happen to B? B will also move on towards the left for a total of 12 meters. No, they have still not yet meet each other yet. So we go on with another trip, and that gives us another 12 meters by 8, 18 meters by 8, and another 12 meters by B for a total of the second meetup. So now, what is the amount of time taken for them to meet for a second time? Wait, for the first meetup, they have traveled a total distance of 30, which is one trip. Now at the second meet, what happens is that, they meet for two entire additional trips. Now that's a total of 3 trips. So at a second meet, the amount of time taken will be 3 times that of the first meet, which is 18 times 3, which gives us 56. And as we go down, we'll realize that for every additional meet, they will need to travel 2 more entire distances. And that tells us, we keep going on, and we should be able to calculate out how many times they meet among these 12 minutes. So with that being said, every additional meet is an additional 36 seconds. Now, let's see how many times will they meet each other then. So first thing, we take away the timing for the first meet. And we know that they have swam for a total of 12 minutes. 12 minutes, how many seconds is that? That is a total of 720 seconds. removing off the 18 seconds from the first meet, that results in us having 702 seconds left. And among these 702 seconds, how many additional meets are there? Let's just divide by 36 and we should be able to see how many more times that they meet each other. No, that gives us 19 with a remainder of 18. Ah, that means they have met for additional 19 times for a total of 20 minutes. And we are very happy with our solution. The question is solved. Is that right? Well, let me tell all of you, that is technically wrong. Why is this wrong? Well, let's read the question properly. Here it says, find the number of times that they pass each other. Well, in our previous part, we have only been dealing with them meeting each other from the front. But when the question is talking about passing, that's another case where they pass each other from the back. Oh, that is not considered when we do this way. So we are not able to use this method where every additional meet is 2 additional trips to solve for the question. Instead, I'll introduce to all of you one new method to solve this type of problems where they pass each other. So here, well, the past, there is a French mathematician called Lewcka. And what he did was he invented this diagram called the Lewcka diagram, where in this case, you want to use it to represent both the distance as well as time to make sure that we can represent all together in one simple diagram. No, he wants to represent time. How can we represent time in this question? What he did was just one straight line, one horizontal straight line to represent it, and let's draw it out. Now, with the time being horizontal, we realize that there's a second thing that we want to represent, and that is, we want the distance. Well, horizontal is already used. What else can we do now? We can only use the vertical part of it to represent our distance. Now, how do we use verticality to represent distance then? Well, he was very genius. He drew another horizontal line, and this distance between the two horizontal lines is the distance that we want to consider. And now, let's see what we do in this diagram. Since we have two of them at the opposite ends of the pool, let's put A at this side and B at the other side. Now for A, when he's doing one trip to the opposite end of the pool, what happens? How long does it take to go to the other end of the pool? Now we see 30-meter pool, 1 meter per second, and that gives us 30 divided by 1, 30 seconds to reach the other end of the pool. Now, with that being said, we know that time is of the horizontal. That means you move 30 seconds to the right side until maybe this point. But at the same time, we want to represent distance. How do we represent distance then? Oh, to represent distance, we want him to swim to the opposite side of the diagram. And that leaves us with a slanted diagonal line. And here it is. Now, with this slanted diagonal line, we can label it as 30 seconds over here. What does he do when he reaches the other side? Of course, you want to swim back And how long does it take? It takes another 30 seconds. And that gives us until here. And again, as it goes back and forth, back and forth, back and forth. But here now, everybody, it is for a total of 12 minutes. 12 minutes is 720 seconds. Can we possibly draw out all 720 seconds in this diagram? Seems like it is not. So maybe we draw a little bit more and we call it a day. No, we'll draw B instead. And for this part, we want to see if there is a pattern that allows us to not draw out the entire 12 minutes. No, let's draw B. For B to do one trip, how long does he take? He takes 30 divided by 2 over 3. And that gives us 45 seconds. Now, B starts from the bottom. And we use a different color to represent him. Well, for him to reach the other side, it'll take a total of 45 seconds. And then back to this and 90. And then again 135 and 280. At this moment, what do we realize over here? Actually, we see A started off from this side. How long does it take to return back to his side? It is every 60 seconds. For B starts at the bottom, and for him to reach back to his own side, it takes 90 seconds. So essentially, when do both of them return back to their original side? It is just the LCM of both 60 and 90, which is represented in this diagram to be 180. At 180 seconds, A is back to his side, B is also back to his side. So essentially, we are restarting the entire process. Now we look at it. We see that every 180 seconds is just one pattern. So now we can take a look at how many times did they pass each other within this 180 seconds. How do we determine that? Now to determine how many times they pass each other, it is just us looking at how many times they have crossed or meet each other on the diagram. And where is that? The first one being here. This is the first overlap that we can find. Here, the second overlap. Here, the third overlap. The fourth overlap. And of course, the fifth overlap. And that is why it is very important for us to draw the diagram using two different colors or two different lines such that we are able to see clearly where are the overlaps. So now there being 5 overlaps. In 120 seconds, we have 5 meets. And in this 5 meets, 180 seconds is just 3 minutes. So for a total of 12 minutes, how many times do they meet? It should just be 5 times 4, which is 20 meets. And there we go, we have our answer of 20 meets within this 12 minutes. We realize that actually the wrong method that we have mentioned also gives us the same answer. But do you remember that is just an exception? That method where every additional meet from the front is 2 additional trips. But if we are just saying them passing each other or meeting, we'll have to draw out our Lewcka diagram. So let's do a quick summary of what we have learned today. When we are dealing with problems that involves people going left and right, back and forth, what do? we draw out our Lewcka diagram to show the relationship between both the time and the distance. And aside from that, well, what else do we do? Well, time is of the horizontal and distance is of the vertical. And that is all that I have to share for this question. Interesting, isn't it? Now we'll look at a practice question. For this practice question, feel free to try the question and put down your answer in the comment section below. With that being said, if you have any other queries, feel free to just join our WhatsApp group, and our teachers at Kangaroo Study will be very willing to help you with any problems that you face. Don't forget, hit the like button and subscribe to our channel below. Thank you and bye-bye.